This video, let's revisit proof by contradiction. So as we recall, proof by contradiction is among the basic methods of proof, and it is somewhat an indirect proof. So to prove something by contradiction, we're going to assume the negation of the proposition, and with that negation, if it leads into a contradiction, then somehow the original proposition is proven to be correct. In the class, we have proven the square root of 2 is irrational by giving a proof by contradiction. So let's solve a quiz problem. So prove or disprove that the logarithm of 5 is an irrational number. So first, let's assume the negation of the proposition. So that means the log of 5 base 2 will be rational. And if you recall, the definition of a rational number is it could produce it into a ratio a over b, for example, where these numbers are, say, integers, and b should not be 0, and a and b have no common factors other than 1. So a, b, no common factors. Other than 1. Okay, so after this assumption, we'll manipulate it algebraically. Say, if we multiply this equation by, say, b, so we'll cancel out the b on the right hand side, and the left hand side this will become b log of 2 or log of 5 base 2 is equals to a. And using simple logarithmic simplification, this b, the coefficient, will become an exponent, so it will go here. So this 5 raised to b. So the equation will become log of 5 raised to b base 2 is equals to a. And since the logarithm is an exponent, so we could say that this one, 5 raised to b, is basically equal to the base, which is the 2, raised to its logarithm, which is a. And in this case, we will have a contradiction. There are basically two ways to come up with a contradiction here. Say 5 is an odd number, and 5 multiplied by another odd number will become an odd number. So this is odd and 2. So as we can, from the definition of an even number, twice of any integer will become even. So that's the first way to come up with a contradiction here. So odd cannot be equals to an even number. Second way to come up with the solution or the contradiction is for these two to be equal. So 2 raised to a and 5 raised to b, you have a and b should be equal to 0, because in that case 5 raised to 0 and twice raised to 0, you will have a 1 equals to 1. So in that case, this will be equal. So that's the only solution for this equation. However, since based on the definition of a rational number, b can never be 0, therefore this solution is a direct contradiction to the assumption, which is the negation of the original proposition. So in this case, this will end up in a contradiction. So odd equals even is the first contradiction. Another contradiction will be the solution to this equation, which will give us 0, which is another contradiction, since b cannot be 0. So therefore, the original proposition, which is log of 5 base 2, is an irrational number. This is proven to be true by contradiction. That's it.